Okay, where do you want me to start?
Every one of them.
I'm doing anything for you. The people that actually
Okay.
try to do
Okay, you want my paper?
Huh?
Want my
Yeah,
paper?
yeah, pretty much just get him out.
No.
These are
I did 1, 2, 3, 4, 5, 6.
All right, number 9.
Very close.
I was impressed.
Limit as r approaches 9 of da 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 da. Any ideas?
Let's back to this. Okay.
Factor it?
Yeah.
It already is factored.
No.
Unfactor it, you mean? Like FOIL it out?
Boil it out. I mean, here we
Okay.
go. R squared minus 3x
You want to
squared
just graph
plus
it?
3.
With the graph?
All right.
Okay.
Do that
Let's
too.
do some. Let's see if we can do this algebraically, though. What? Can we do this algebraically? Yeah. If you look at the graph, it's infinite. The way the book cheats and wants to do it is they basically are saying, let's think about this. Let's think about if r is just a little bit bigger than 9. What are you going to get down here? Or let's say, what are you going to get up here? Yeah, pretty close to 3, right? And what are you going to get down here if you go 9.000000001 minus 9 and then take it to the 4th power? A really, really, really small number. So this is really small. Okay? And 3 divided by a really, 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 really small number is going to be a big number, so we're going to say infinity. Then you need to think about if r is just on the other side of 9, because it's possible that you could have, if you weren't looking at the graph, it's possible that at 9, one part could go this way and one part could go that way, right? Which would mean that there would be no limit. So you've got to check both sides of 9. So if you put this in here, you get a really, 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 really small negative number. But then what happens when you take that really small negative number and raise it to the 4th power? It becomes positive. So you're in the same situation here where you have basically 3 over a really small number, which is infinity. Okay? So the only way really to do this without looking at the graph is just to sort of think about what's happening around 9. Okay? Yeah.
Can you do 6 algebraically?
Probably not, but we can try.
I don't even know.
Okay, so do you try factoring it?
Yeah.
The obvious.
X plus 3.
X plus 3 and x minus 1 on the bottom?
Yep.
Okay. So those factor, which isn't helpful, right? Because we want, is this one from the positive side?
Yeah.
Okay, so let's play the same game that we were doing on the other one. If I put in a number just larger than 1 there, what am I going to get? A really small number. So on the bottom I'm going to have a really small, but it's positive number, right? Okay. And then if I plug in a number just bigger than 1 here, what am I going to get? Pretty much negative 2. Okay? So what's negative 2 divided by a really small positive number? Somewhere around negative infinity. We could make that as big a negative number as we wanted to if we chose a really big. So that's how that's going to go. Okay? Anything else?
23.
Yeah. 12.
All right.
Okay, what do you do? We could do that. We'd have to plug it in like 2.99999 and then 3.0001. You know, you have to check both sides. But let's see if we can't do the conjugate thing. And I don't know if this is going to work or not. It's not going to be as bad as you think, because square root of x plus 6 times square root of x plus 6 is, well, Oh, right, okay, x plus 6. And then we don't have to do the inside and the outside because those will cancel, right? That's the whole idea behind choosing the conjugate. And then negative x times x is negative x squared. And then the reason why it's not ugly on the bottom is because we don't have to FOIL that out. We're going to leave it as this times, I'm sorry, I didn't see you cutting you off, square root of x plus 6 times x. Okay? What do we get from that? Well, let's simplify the top first. X, oh, I guess we can. Okay, this is going to be fun. So you can factor out an x squared from the bottom, right? So we're going to pull out the x squared there and make this x minus 3. Okay, this is awesome. This is a great problem. This should probably be on your test. And then you can actually factor the top. Okay? And the way I'm going to factor the top is I'm going to rewrite it as negative, parentheses, x squared minus x minus 6. And waka waka waka. Okay? So I did the negative thing to get it in the form that we know and love, where the x squared is positive and everything works. Okay, so what does that factor
X
into?
minus 3 and
I
x.
guess I can do this up here. So it's going to be negative x minus 3 times x plus 2. The x minus 3 cancel, and now you can plug 3 in there. Okay? So 3 plus 2 is 5, but it's negative, so it's going to be negative 5. So I plug 3 in there, I'm going to get 9 times square root of 9 is 3, plus 3 is 6. So it's going to be negative 5 over 54. How do you like that? Lovely. Okay, so that's a little tricky with all this extra factoring. What did you get? Right. And you got the right answer?
Yeah, well, not 2. That's what.
Okay, well, it's got to be the 8 decimal place, so you're kicked off the island. Okay? Did what I did there, did that make sense?
Yeah.
Okay. I know that you wouldn't necessarily been able to come up with that on your own, but at least you understand what we got going. Okay. Anything else? Shadwick?
23.
23. Well, right, so, and the reason why they restricted it to x being less than 0 is because this is negative x, right? So if you plug in, let's do an easy one, negative 9, what do you get as your answer? 3. And if you plug in negative 4, you get 2. Negative 1 gives you 1. And if you could plug in 1, but it says not to, I mean, if you could plug in 0, you would get 0. Okay, so what this is the square root function, but it has been reflected over the y-axis, which I'm sure you remember from last year, that if you change the x to a negative x, there, see, I'm sure you remember from last year, then that has the effect of reflecting the graph over the y-axis. So that's what that piece will look like. Next piece is y equals 3 minus x, and that's in between 0 and 3, so that looks like a straight line. Y-intercept of 3, and that gets the closed dot, right? Because it says can equal 0, and it has a slope of negative 1, so that's going to go down here and then have an open circle at 3. And then it is x minus 3 quantity squared when x is greater than 3, so what does that look like? Parabola, moving, it's got shifted to the right, so it's going to look something like that. Okay? Thank you. All right, so there's the graph. Now we can use that to find the limit. So what's the limit as x approaches 0 from the positive side? 3. What's the limit as x approaches 0 from the negative side? 0. So what's the limit as x approaches 0? Does not exist if the left and right hand limits are different. What's the limit as x approaches 3 from the negative side? 0. What's the limit as x approaches 3 from the positive side? 0. What's the limit as x approaches 3? 0, because those are the same. Okay? Where is f discontinuous? Right there at x equals 0, and right there at x equals 3. Okay? All right, anything else? Show that each function is continuous on its domain. All you have to do is say it's a composition of a root function, a polynomial, a trig function. Those are all continuous, so that's continuous. Okay? Same thing with 26, then you say it's a root function, a polynomial, rational function, continuous on its domain. Okay? Good enough? Okay.